Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 10, that is the file structure and the storage, that is how to store the data and what is the file structure that is used in the storage. Right. So let's start with the previous class session, that is what we have covered in the last class, that is in the yesterday's class. Then moves to the next topic, that is a today's topic, that is how to make the file storage. What are the various advantages of file storage, that is how to make the file storage possible. So let's start with the previous class session what we have covered in the last class, then move to the today's topic. So in the last class we have started with the part number 3, that is the data storage and the querying, that is how to store the data and how to query the data, that is the data storage and the querying. So in this we have studied about what is the data storage and what is the need for the data querying, that is how to manage the data or database, that is the data storage and querying. So although a database system provides a high level view of data, ultimately the data have to be stored as a bit on a storage devices. After all, the data has to be stored or have to be stored as a bits on the storage devices. A vast majority of databases today store data on the magnetic disk and fetch that data into the main memory for processing. That is how to store the data on the magnetic disk, and how to we can say the store the data on the secondary memory on the secondary devices like hard disk, floppy disk, or the we can say the magnetic disk. The physical characteristics of storage devices plays a major role in the way the data will be stored. Chapter number 10 begins with the overview of the data storage, that is what is the data storage and how to deal with the data storage. And we also started with chapter number 10, that is the storage and the file structure, that is how to store the data and what is the file structure. So in this chapter we will study about what are the various storage devices and what are the various file structure that is used in the storage devices. So in the previous chapter, we viewed the databases as a conceptual or the logical model, that is a collection of the basic tables. That is, a logical model is the correct level of the user to use on. So this is the correct level of the model or correct level that by which the user can use the data. That is a correct data storage that is used by the databases. Now, then we have covered about the overview of the physical storage media, that is the how to store the data or what is the overview of physical storage media that is available. So several type of data storage exist in most computer systems. These storage media are classified by the speed with which the data can be extended. There are many storage devices that exist in the many computers, and these storage devices are classified, or we can say it is divided into multiple parts based on the various devices or based on the various media or based on the we can say the speed by which they can access, and by the cost per unit of data to by the medium, and by the medium capabilities or reliability. That is what is the speed, what is the cost, and what is the medium reliability, how we can rely the data or how we can make the data or make the database possible. That is the reliability, cost, and the speed. So on the basis of the physical storage media, it is divided into multiple parts. That is how to store the data in the physical medium. So first part is the cache memory. That is a cache memory in which we can store the data. That is it is a fast memory that is very close to the internal memory, or we can say that is very close to the CPU. So its access time is very higher than the other types of memory. So this is a cache memory. So in this the access time is higher. So it's one of the main advantage that it is very speedy memory. The data we can send or the execution that we can do is very easy memory. Then next is the main memory, that is the internal memory, that is we can say the RAM, that is a random access memory in which we can store the data. The main goal of this memory or the general purpose of this memory with that is the main memory that is used with various gigabytes, that is used with various personal computers. Then there is a flash memory, that is a memory that is different from the main memory. In this we can retain the data even when the power is turned off. Even when the power is turned off, we can also retain the data, we can also deal with the data. Then magnetic disk storage, that is how to store the data on the magnetic disk, that is also a physical storage medium. Then there is the optical disk, that is the CD-ROM, and the DVD, that is a compact disk read-only memory, and there is a DVD, that is a digital versatile disk or digital video disk. Then there is a tape storage, that is how to store the data on the tape. That is a tape storage that is available in this one. That is next part. Then there is a tape storage also, that is we can store the data on a tape also, that is a magnetic tape, that is a tape storage. So these are the various storage media that is used, that can be organized into various hierarchy, that is a cache memory, main memory, internal memory, cache memory, magnetic disk, and the tape storage. So these are the various, we can say, the hardware storage media or the physical storage media by which or in which we can store the data. And these memories are organized in a hierarchy according to their speed and the cost. So there are multiple speed, there are multiple cost of the each of the table, each of the hierarchy that is used with the speed and the cost. So these are the various storage media that can be organized into hierarchy, that is according to their speed and according to their cost. The high levels are expensive but are fast. That is the high level, we can say the high level memories or high level physical storage media are the expensive memory, but they are fast memory. That is, their speed is very fast as compared to the other memories. The faster storage media that is available, for example cache and main memory, are responsible or referred to as primary storage. The media in the next level in the hierarchy, for example, magnetic disk, are refers to as secondary storage, online storage. The media in the lowest level in the hierarchy, for example, magnetic disk and the optical disk, are refers to as the tertiary storage or the offline storage. So media in the higher level, in the next level in the hierarchy, refers to as the, or the first level that is available, that is known as the cache and the main memory. And the next level hierarchy, that is known as the magnetic disk, that is also refers to as the secondary storage or the online storage. And the media that is available in the lowest level, that is known as the tertiary storage or the offline storage. So these are the various devices. One is a primary memory, then secondary memory, then there is a tertiary storage. So three types of storage: primary, secondary, and the tertiary. And the secondary is also known as the online storage, and the tertiary, secondary is known as the online storage, and the tertiary is known as the offline storage. In addition to the speed and the cost of the various storage devices, there is also issue of the storage volatility. That is, a volatile storage loses its content when the power to the device is removed. So when the power is removed, when the power has gone, then the storage device will be closed. That is known as the volatile memory. And this is the, we can say, the diagram that shows various types of memory. There is a cache memory, main memory, flash memory, magnetic disk, optical disk, and the magnetic tapes. Then we also discuss about the magnetic disk and the disk and the flash storage, that is how to store the data, how to we can say the adjust the data in the magnetic disk and the flash storage. So magnetic disk provides the bulk of secondary storage for modern computer system. Although disk capacities have been growing year after year, the storage requirements of the large applications have also become growing very fast, and in some cases even faster than the growth rate of the disk capacities. A very large database may require hundred of disks or hundred of disks that is available. In the recent year, flash memory also has been repeated, or the, we can say, the grown in a rapid way, and the flash memory is also increasing in the magnetic disk storage for the various applications. Then one of the feature, or one of the point, we can say, the one of the essential component of the magnetic disk is the physical characteristics of the disk. That is, there is a physical division of the magnetic disk that is divided into multiple parts, that is known as the platter. So this is one platter, platter 2, platter 3, and these are the various tracks and the sector. This is a spindle motor that moves around, moves around, moves around. The read-write head stores information on a sector magnetically as reversal of the direction of the magnetization of the magnetic material. And there is a read-write arm, there is a disk arm that is also available, and there is a head disk assembly that is also available with the disk platters. There is a disk controller that also provides an interface between the computer system and the actual hardware of the disk drive. So there is a disk controller that provides the interface between the computer system and the actual hardware of the disk drive. And there is a checksum that checks the sector, that checks the data that is written into the sector. Then we will also discuss about the performance measures of the disk, that is the access time, that is equals to the seek time plus the latency time. There are two times, one is the seek time, one is the latency time that is available. So if I want to reach on the sector, that is done by the, that is known as the seek time, and when I want to reach on the track, that is known as the latency time. So access time is equals to the seek time plus the latency time. That is a combination of the both seek time as well as the latency time. That is the performance measure of the disk. That is how to measure the performance of a disk. And there is a latency time, there is a average latency time, there is a MTTF, that is a mean time to failure. Then optimization of the disk block access, that is how to optimize the disk block access. So a block is a logical unit consisting of a fixed number of contiguous sectors. And the page refers to the number of blocks, although in the few contexts that they refer to the different things. A sequence of requests for blocks from the disk may be classified as a sequential access pattern or a random access pattern. In a sequential access pattern, sequence or the successive requests for successive blocks number are on the same track. And these are the various techniques that is used to improve the access, or that is used to improve various improve the speed of the access to the block. That is how to improve the speed of the access that is available. So one is the buffering, that is the buffering is one of the technology to increase the speed. Then there is a read ahead, that is also available. Then there is a scheduling, then there is a file organization, then there is a non-volatile write buffers, and there is a log disk. So these are the various devices that is available, or these are the various techniques that is available to increase the performances of the devices or the performances of the properties. Then there is a flash storage. What is a flash storage? What is how to use the flash storage? Then we have discussed about the RAID, that is a redundant array of independent disks. That is also a storage medium in which we can store the data that contains various independent disks. That is a redundant array of independent disk. A variety of disk organization techniques, that is known as a redundant array of independent disks, that is a RAID, have been postponed to achieve the improved performance and reliability. In the past, system designers view storage systems consist of several small cheap disks as a cost-effective alternative to using large, expensive disks. The cost per megabyte was less than of the larger disk. So that is also available. There is an expensive disk, there is a large disk that is also available with the storage devices. Then improvement of the reliability via redundancy, that is there is an improvement that is also available in the reliability and the redundancy. So the solution of the reliability that is available is to introduce the redundancy, that is we can store the extra information that is not needed normally, but we can use the data in case of the failure to rebuild the lost information. And there is another approach that is also used to introduce the redundancy, that is the mirroring. That is the technique is known as the mirroring. And there is a mean time to failure that is also available, that is mean time to repair. Then next point is improvement in performance via parallelism. That is how to improve the performance and what are the various parallelism technique that is available with the improvements. So it is the improvement in performance via parallelism. So we can consider the disk, we can consider the performances, we can consider the parallelism that is available. We can improve the performance with the help of the magnetic disk. And there is a RAID 0, that is a non-redundant stripping. Then there is a RAID 1, that is a mirrored disk. RAID 2, that is a memory strike error correcting code. Then bit interleaved parity. Then there is a block interleaved parity, and then there is a block interleaved distributed parity. And RAID number 6 is P plus Q, that is a P also uses the P terms. That then we have discussed about the RAID level, that is what are the RAID level, various RAID level that is available with the RAID terms, that is a RAID 0, 1, 2, 3, 4, 5, 6 that we have discussed. There are total 6 RAID level that is available with the RAID. Then how to choose or how to choose the RAID level, that is which RAID level is very high. So the first one factor that is taken into account is the monetary cost, that is how much money is required for the RAID level, that is the monetary cost of extra disk storage requirement. Then performance requirement, that is how to perform the measures or what are the various performance requirements in terms of the number of input output operations. Then performance when a disk has failed. Then performance during rebuild. So these are the various choices that is available with the RAID levels. Then the time that is required to rebuild the data of a failed disk can be significant and it varies with the RAID level that is used. The rebuild performance of a RAID system may be an important factor if continuous availability of data is available. It shows the high performance database systems. Then there are different there are different RAID level that is also available with the data disk. Then there is a hardware issues, that is what are the various hardware issues that is available with the RAID levels. So one of the main issues that is available is the hardware issue as well as the software issues. Then we have also discussed about the tertiary storage, that is the optical disk that contains the CD-ROM and the optical disk. Then there is a magnetic tape, that is a tape that stores the data in a magnetic tape style. And the tape is kept in a spool and it is wound or rewound past a read-write head. Then next is the file organization, that is how to organize the file, that is organized in terms of the block. So there is a fixed length blockage or there is a variable length blockage that is available with the file. So this is the today's topic, that is a file organization. And this is also the today's topic, that is what are the various tertiary memory that is also available with the data storage, that is a tertiary memory. So in a large database system, some of the data may have to reside on the tertiary storage. So this is also the tertiary storage, that is how to use the tertiary storage. And one of the main feature or one of the main storage is the optical disk, that is how to use the optical disk in the tertiary. So next is the tertiary storage, that is what is the tertiary storage and how we can store the data in the tertiary storage. So in the large database system, some of the data may have to be resist or they may have to be reside on the tertiary storage. The last two common tertiary storage media are the optical disk and the magnetic tape. So there are two storage devices, the two most common tertiary storage media, that is known as the optical disk and the magnetic tapes. So first is the optical disk, that is what is the optical disk, how to use the optical disk. So compact discs have been a popular medium for distributing the software, multimedia data such as audio and the images and other electronically published information. They have a capacity of 640 to 700 MBs. Then they are cheap to mass produce. DVDs have now been replaced with in most applications where we want to receive the large amount of data. Suppose I have a data of the 5 GB. I want to store it and I don't have a pen drive. So I will store the data in the DVDs, that is a digital versatile disk that have a capacity of the 4.7 gigabytes of data. While the disk in the DVD 9 can store 8.5 of data of the gigabyte of the data, that is in the two recording level. So it depends on the DVD to DVD, but the common DVD stores 4.7 GB of the data. Recording on both sides of a disk yields even larger capacities. So there are multiple facilities, multiple formats that is available like DVD 10, DVD 18, which are two-sided versions of the DVD 5 and the DVD 9 that can store 9.5 gigabytes and 17 gigabytes respectively. And the Blu-rays DVD format that have significantly higher capacity of 27 to 54 gigabytes per second. So they have high capacity as compared to the DVD format that is available with the higher capacity. CD and the DVD drives have much longer seek times than do magnetic disk drives. So they have high speed time, they have a much larger seek time that is available with the magnetic disk. Since the head assembly is heavier, rotational speeds are typically lower than that of the magnetic disk, although the faster CD and the DVD drives have a rotation speed of around or about 3000 rotations per minute. And the data transfer rates are somewhat less than for the magnetic disk. Current CD drives that can be used that can around 3 to 6 megabytes per second, and the current DVD that is used that can store or that can read 8 to 20 megabytes per second. Like magnetic disk drive, optical disk stores more data in the outside track and less data in the inner track. So it is used as a CD and the DVD. So first of all there is an optical disk that contains two parts. One is the CD, one is the DVD. And the recorded once version of optical disk, that is the CDR, DVD-R and the DVD plus R, are the most popular distribution of data, and particular for the archival storage of data, because they have a capacity, they have a longer lifetime than the magnetic disk. So these are the various capacities, or we can say these are the various versions that is available with the optical disk. And there is a CD-RW, that is a read write, then DVD read write, then DVD plus read write, then DVD RAM are also used for the archival purposes. Jukeboxes are also the device that they can store a large amount of or large number of optical discs that is available. Then there is a magnetic tapes that is also available, that are also the part of the optical disc, or that is also the part of the secondary storage, or the we can say that's a tertiary storage. So first is the optical disc that contains the CD and the DVDs. Then there is a magnetic tapes that is also a part of the tertiary storage. So although magnetic tapes are relatively permanent and can use and can hold large volume of data, they are slow in comparison to the optical and the magnetic disk. So although they are permanent disk, but they have a large volume of data, they are but they are slow in comparison to the magnetic and the optical disk. That is, their speed is very slow as compared to the magnetic disk, as compared to the optical disk. Even more important, magnetic tapes are limited to the sequential access. That is, they are also limited to the sequential access, because there is no sequence of the data. We can store the data at the random. Then tapes are used mainly for the backup, for storage of infrequently used information, as an offline medium for the transferring the information from one system to another system. Then a tape is also kept in a spool, that is, we can kept the tape in a spool, that is, it is wound or rewound past a read write head. So there is a spool, that is a weird, or that is a tape that contains the read and the write head. And these are the various terms that is used. There is a digital linear tape, that's a DLT, that format that contains the 100 gigabytes, or we can say it contains the 330 gigabytes with a minimum of we can say the minimum of the format that is available. And there is a data transfer rate that has few of the 10 of the megabytes per second. Next is the file organization. That is the most important concept. That is how to organize the files, or we can say how to manage the files. That is a file organization. In simple terms, organizing means how to organize, and when to organize and how to organize, that is a file organization. So a database is mapped into a number of different files that are maintained by the underlying operating system. So a database that is maintained, or database that is taken up, that contains multiple files or different files that are maintained by the underlying operating systems. And these files resides permanently on the disk. So these are the disks that is available. There are disk file that is available on the disk, that is a permanent files. A file is organized logically as a sequence of records. So what is a file? That is a sequence of record. That is a file. And the most important concept of the file is that it can store on a physical storage medium. And these records are mapped on a disk blocks. And files are also provided as a basic construct in operating system. And we can also use, or we can also say, the file system, that is a collection of files, or we can say a systematic file arrangement that contains various files, that is a file system. And each file is also logically partitioned into the various blocks, that is known as the blocks. So first of all, there is a file that stores the records, and each file is divided into the physical storage, physical blocks, that is known as the physical part, that is known as the blocks. And we can store the data, we can access the data with the help of the blocks, with the help of the data transfer. And most of the database uses a block size of 4 to 8 kilobytes by default. That is the main capacity, that is the 4 to 8 kilobyte that is available with the data transfer. And large block size can be useful in some database applications. In addition to this, we can also require that each record is entirely contained in a single block. That is, each block is entirely contained in a single block. So when we divide the file into various blocks, and each block contains various files, each block contains various or a single block. That is, no record is contained partly in the one block and partly in the another block. And according to them, they are divided into two parts. One is a fixed length record, that is their length record, their capacity, their block cannot be changed again and again. And next is the variable length, that is their rules, their length, their values are changed from the time to time. So this is the fixed length records. This is the example of the fixed length record. And there is a file header that contains the headings. We can say the column headings. There is a free list, and there is a variable length record that is also available in this one. So variable length records arise in database system in different ways. First one is storage of multiple record types in a file. That is how to store the multiple records in a file. Then record type that allows variable length for more or one or more fields. Then record types that allows repeating fields such as arrays or multi-cell. That is, there are variable length, we can store the data, we can remove the data, we can increase the data in the variable length storage. The representation of a record with a variable length typically includes or typically has two parts. One is the initial part that has a fixed length attribute, and one is the variable length attribute that get there or that have their varchar types. This is a representation of the variable length record. This is the bytes. These are reserved 0 to 4, 4 to 8, 8 to 12, 12 to 20, 26, 36, 45. And there is a page structure that is available that is known as the slotted page structure that is commonly used for organizing the records within a block. The number of the records that is also required in the header. At the end of the free space in the block, an array whose entries contains the location and the size of each record. Then next is organization of the records in a file. That is how to organize the records in a file. That is the organization of the records in a file. So far we have studied how records are represented in a file structure. That is, what is the file? That is a collection of the records, or that is a collection of the information. A relation is a set of records. That is, a table is a set of records, or relation is a set of records. So we can call the table as a relation. Given a set of records, the next question is how to organize them in a file. That is, how to organize them in a file. Several of the possible ways of organizing the file. That is, there are different methods for organizing the files, or organizing the records in a files, or organizing the information in the file. That is a heap file organization. So first of all, there is a heap file information that is available. Any record that can be placed anywhere in the file where there is space for the record. There is no ordering of the records. Typically there is a single file for each relation. That is, there is a single file that is available with each relation. Then there is a sequential file organization. So one is a heap file organization that can contain or that can be placed anywhere in the file where there is a space for the record. Then there is a sequential file organization in which we can store the records, or the records are stored in a sequential order according to the value of a search key of each record. That is a sequential file organization. That is, in a sequence we can store the data in a sequential order, that is one after the another, another after the another, another after the another. That is a sequential file organization. Then there is a hashing file organization that is computed on some attributes of each record. That is also available, or that is also available in the block of the file the record should be placed. That is a sequential file for the instructor record. So this is the sequential file. There is a 1011 Srinivasan computer science 65. After that there is another record. After that there is another record, another record, another. These are sequenced in terms of their numbers. That is a 1210101, 12121, 15151, and so on. 3334558767767, 765, then 838, then 8321. And these are the various, we can say, the file organization that is available. So we are talking about in detail, that is a sequential file organization. That is a one after the another the data will be stored. That is in a sequence. That is a one data will be stored, then another data, then another data, then another data. That is a sequential file organization. So a sequential file is designed for efficient processing of records in sorted order based on some search keys. That is, based on the search keys, we are a sequential key, we have a sequential data that is available with the sequential memory. A search key is any attribute or set of attributes. It need not be the primary key or not even a super key. So it does not have a primary key, it does not have a super key that is available. To permit the fast retrieval of records in a search key order, we chain together records by the pointer. So there is a pointer that is also available for changing the records. The pointer in which records point to the next record in search key order. Furthermore, to minimize the number of block access in sequential file processing, we store the records physically in the search key order or as close to search key order as possible. That is, the records are stored in a physical storage media, that is a sequential file structure in which we can store the data one after the another. Figure 10.10 shows a sequential file of instructor records that is taken from our university example. In that example, the records are stored in a search key order using a ID as a search key. The sequential file organization allows records to be read in sorted order that can be useful for displaying the or display the purposes. That is, they are also read out in a sorted order, that is, we can arrange in a sorted order, that is, a one after the another. And it is also difficult, however, to maintain physical sequential order in which the data will be stored. Or also the managing the deletion, managing the addition is also easier. So for insertion, the following rules are followed. That is, if I want to insert the data, if I want to insert the rows, that is, what are the rules that is followed? First of all, locate the record in the file that comes before the record to be inserted in a search key order. That is, locating the records in a file that comes before the record to be inserted. So first of all, locate the row before which you want to search the data, before which you want to insert the data. If there is a free record, that is space left after a deletion, that is in the same block as this record, insert the new record there. So first of all, there is a free record. If for example, if there is a free record within the same block, insert the new record there. Otherwise, insert the new record in an overflow block. So if there is a free block that is available, insert the record, and if there is a new block that is a blank record that is available, so there is a overflow block. In either case, adjust the pointers so as to chain together in the search key order. So chain together or adjust the pointer in the chain together so as to maintain the search key order. Figure 10.1 shows the files of figure of 10.10 after the insertion of the recorded material. The structure in figure 10.11 allows fast insertion of the new records but forces sequential file processing application to process the records in the order that does not match the physical properties of the records. At this point, the file should be reorganized so that it is once again physically in the sequential order. Such reorganization are costly and must be done during times when the system load is free. Then next is the multi-table or the multi-table clustering file organization. That is, what is the file organization and how to make the multi-table or the multi-table clustering file organization. That is, we have to maintain the multi-table, we have to maintain the multiple table that is used, and how to organize the files. That is a file or a multi-table clustering file organization. So many relational database systems stores each relation in a separate file. There are separate file that is available for the relation, that is available for the tables that is used, so that can take the full advantage of a file system that the operating system provides. Usually the tuples of a relation can be represented as a fixed length record. So there is a fixed length record that is available with the tuples. The simple implementation of a relational database system is well suited to the low cost database implementation that is used. And the simple approach, the relational database implementation becomes less satisfactory as the size of the database increases. However, many large-scale database systems that do not rely directly on the underlying operating system for the file management. Even if multiple relations are stored in a single file, by default, most databases store records of one relation in a given block. This simplifies the data management, that is, how to manage the data or how to manage the records. So this is one of the example, that is one of the SQL query, that is select the department name, building, budget, ID, name, salary from the department, natural join instructor, that is these two tables are joined and these fields are extracted from these table. So this is the department table, and then this is the instructor table. A multi-table clustering file organization is a file organization such that it is illustrated in 10.14, like this one, that is a multi-table file organization. Such a file organization allows us to read the records that would satisfy the join condition by using one block record. Therefore, we are able to process this particular query more efficiently. In the representation, the department name attribute is omitted from the instructor record. So there is no department name that is available from the instructor record that is used with the data storage. So it can be referred, or since it can be referred from the associated department record. So the attribute may be retained in some implementation. That is, they are available from that, we can say they are available from the next record from the department record. Our use of clustering the multiple table into a single table enhances processing of a particular join, that is a department and the instructor, but it results in the slow processing of the queries, that is also used. Next is the data dictionary storage, that is how to store the data in a data dictionary. That is the next topic that I'm going to start after the break. So let's take a break right now, then move to this topic, that is a data dictionary storage. So let's take a break right now. Come back from the break. Now let's start the session again. So next part is the data dictionary storage, that is how to store the data in a data dictionary form, that is the data dictionary storage devices. So far we have considered only the representation of the relation themselves, that is how to represent the relation or the table themselves. A relational database system needs to maintain data about the data, that is one data is related to the, or one table is related to the own table, that is a data about the data. That is a relational data system that needs to maintain the data about the data, or the data about the relation. That is how to maintain the data, how to maintain the relation about the relation, such as the schemas of the relation. That is, schema means the logical design of the relation. In general, the data about the data is referred as the metadata. So there is a metadata that is available, that is the data about the data, and there is a relation schema that is available, that is used, and there is a metadata, that is a relation that is stored in a structure that is known as the data dictionary or the system catalog, that is available with the data connections. So this is the data about the data, that is the data dictionary relation that is used with this one, and this is the information that is available in the data dictionary, that is name of the relation, that is what are the name of the table that is used in this one, what are the name of the attribute that is used in the relation, that is next is the name of the relation, that is what are the various relations that is available with this one, what are the various tables that is used in this one, and the name of the attributes of each relation, that is what are the various column headings that is available in the relation, then domain and the length of the attribute, that is what are the domain and what is the length of the attribute. So we can say what is the length of the, or what is the variable length of the attribute that is given in this one. The name of the views that is defined in the database and the definition of those views. So these are the various information that is stored in the data dictionary. As we said, that data dictionary is the data about the data. So there is a storage of the data that is available, that is every information that is related to the table. So these are the various views that is defined in the database. So, and there are various definitions. There is a integrity constraints, that is the key or the constraint that is available in the database that is used in this one, that is used with this one, that is the data about the data that is available in this one, that is used with this one, that is the data will be available with the database, that is the data about the table. Then name of the views that define the database and the definition of the these on these views. Then next is the integrity constraints, for example the key constraints. In addition to this one, many systems give the following data on the users of the system. Now what are the various data that is available about the users? That is the name of the authorized users, that is what is the name of the authorized users, then authorization and accounting information about the users, that is how to make the authorization or how to use the authorization techniques, that is there will be a matching of the username and the password, then only the user will be authenticated user, that is matching the username and the password. Then on what are the relevant information that is needed for this one, that is the name of the authorized user, then authorization and accounting information, that is the related information, accounts information that is related with the users. Then password or other information that used to authenticate the users. There is also information that is available with the user to authenticate the users, that is authentication is provided, that is we can say the uh, deal with the customer or deal with the user, whether the customer or whether the user is valid user or not. Furthermore, the database may also store the statistical and the descriptive data about the relation. So these are the various, we can say the data, we can say the data about the data is available in the relation. That is, more and the more data will be stored in the databases, more data will be stored in the data dictionary. That is the data about the data. And furthermore, the new relationship or the new database or the new, we can say the concept that is used in this one, that is used to, or that is stored in this one. The first one is the name of the tuples in each relation. That is, what are the name of tuples in each relation, or we can say what is the name of the each row that is available in each relation. Then method of storage for each relation. That is, what is the method that is used with this storage. That is, what is the method that is used in this storage. So number of the tables in each relation, method of the storage for each relation. What is a method? For example, there is a clustered method, there is a indexed method, there is a non-indexed method, there is a non-clustered method. The data dictionary may also note the storage organization. So the data dictionary is also available with the data organization, that is how to organize the data, that is either in the sequential form, hash form, and heap form. We have also studied about the file organization, that is there are multiple file organization that is used in this one, that is either the organization may be in the form of sequential order, either the may be in the terms of heap, either maybe in terms of the hash, and the location where each relation is stored. So it also note the, or it also stores the organization, or the, we can say the capacity or the information about the storage organization where each relation is stored. Now first one is, if a relation or if relations are stored in the operating system files, that is if the relations that are stored, if the tables that are stored in the operating system files, the dictionary would note the name of the files containing each relation. That is, a dictionary that is also available would note the amount of the file that is also available for each data storage. Next, if the database stores each relation or all relation in a single file. So first of all, every relation is stored in a different files, in a different operating system files. Next, every database or in a single database there is a multiple relation that is stored in a single file. The dictionary may note the blocks containing records of each relation in a data structure, such as the linked list. So linked list means one node is related to the another node. In one node there is a node, there is a information, there is a address, and each node is connected with other node by use of the address. That is a linked list. That is, a list will be maintained in a sequential order. There is a node, there is a data, there is a address, and one address of one node and address of one node is related with the address of another node. In chapter number 1, in which we study the indices, we shall need a, or we shall see a need to information, or we'll see need to store the information about each index on each of the relations. So first one is, what are the various information that is stored about the indices. That is the name of the index, then name of the relation being indexed, that is what is the index, what is the criteria to search out, what is the name of the relation that is being indexed, what are the attributes on which the index is defined, and the type of index form. So these are the various information that is used to store the information about the index. That is the name of the index, and name of the relation being indexed, attribute on which the index is defined, and the type of index forms. All this metadata information constitutes in effect a miniature database. So all the information that is used, it contains a miniature database, that is a mini database that is available with the database system. Some database system that is available that also stores the metadata, that is the data about the data, by using the special purpose data structure. So there is a special purpose data structure that is also available to store the data, that is known as the data about the data, that is a metadata. The index metadata relation is therefore not in the normal form. It cannot be normalized. This is one of the example of the metadata. This is a relation underscore metadata, then attribute underscore metadata, then index underscore metadata, and the user metadata. So these are the various relations. This is the relation name, the name of the number of the attributes, then storage organization, location, relation name, attribute name, domain name, position, length. So these are the various relations, these are the various data about the data. Then there is the index metadata that also contains the index name, relation name, index type, and the index attributes. And there is a user metadata that is also available with this one. There is a username, encrypted password, and the group. Then there is a view database or the view metadata that is also available, that contains the view name and the definition of the data. So this is a relational schema that represents the system metadata that is available with the system database. That must be recorded elsewhere, that we store the information to find the content of the relation metadata. So these are the, we can say, the 5 relation metadata that is available. One is a relation metadata, then attribute metadata, user metadata, and the index metadata. And there is also a view metadata that is available. Then the next one, or the next topic, is the database buffer. That is, a database buffer means where to store the database. That is a database buffer. So let's start with the database buffer. So this says a major goal of the database system is to minimize the number of block transfer between the disk and the memory. So there will be a minimal number of disk transfer, that is transferring the disk between the block transfer between the disk and the memory. One way to reduce the number of disk accesses is to keep as many as blocks as possible in the main memory. So one of the way to reduce the disk access is to keep many blocks as possible in the main memory, so that the transfer rate between the blocks is also kept minimum. So minimize the number of blocks is very essential for transferring the data between the disk and the memory. The goal is to maximize the chance that when a block is accessed, it is already in the main memory, and therefore no disk access is required. So when a block is accessed, it is already in the main memory, and therefore there is no requirement of the disk access that is required. Since it is not possible to keep all the blocks in the main memory, we need to manage the allocation of the space available in the main memory for the storage of the blocks. So it is also it is not possible to keep all the blocks in the main memory. So this is not also possible to keep the blocks in the main memory. We need to manage the allocation of the space available in the main memory for the storage of the. So buffer is that part of main memory that is available for storage of the copies of the disk blocks. So what is a buffer? That is a part of the memory, part of the main memory that is available for storage of copies of the disk blocks. That is a buffer. There is always a copy kept on the disk of every block that is available with the different versions of the buffer. The subsystem that is responsible for the allocation of buffer space. So when we allocate the various buffer, when we allocate the buffer space that is available, that is known as the buffer manager. So buffer is a memory, or buffer is a main memory, or part of the main memory that is available for storage of copies of the disk blocks. So the subsystem that is responsible for the allocation of the buffer space, that is known as the buffer manager. Now, what is a buffer manager? That is a manager that manages the buffer. So programs in a database system make requests, that is calls, on the buffer manager when they need a block from the disk. So whenever there is a need of the block from the disk, there is a buffer manager that manages each and everything from the blocks. If the block is already in the buffer manager passes the address of the block in the main memory to the requester. So what is the role of the buffer manager? That is manages the buffer so that it will be kept lying, or it will be managed by the buffer management. And if the block is not in the buffer, that is, it is not available in the buffer, then it is transferred to the next block. It is transferred to the first allocated space in the buffer for the block, throwing out some other blocks if necessary to make the space for the new block. The thrown out block is written back to disk only if it has been modified since the most recent time it was written to the disk. Then the buffer management reads the requested block from the disk to the buffer and passes the address of the block in the main memory to the requester. So if there is a storage, if there is a disk buffer that manages the disk, that manages the blocks, that manages the concept that is requested to the, or that is available to the requester. The internal actions of the buffer manager are transparent to the programs that issues disk block request. That is a internal action that is available with the buffer management or the buffer manager are transparent or are visible to the programs that issues the disk request or that issues the disk block request. Now, to serve the database system well, the buffer manager must use the techniques more sophisticated than the typical virtual memory management scheme. So there will be a storage of the data, there will be a database system that manages the buffer. So buffer management uses various techniques to manage the buffer. Now, what are the various techniques that is managed by the buffer, that is managed by the disk buffer? First is buffer replacement strategy. So there is a strategy that is also used by the buffer manager to manage the concept is the buffer management or buffer replacement strategies, that is the LRU, that is the least recently used. So when there is no room left in the buffer, a block must be removed from the buffer before a new one can be written. So if there is no room that is left in the buffer, I'm so sorry. So a block must be removed from the buffer before a new one can be written. Most operating systems use a least recent use, that is a LRU, that is a least recently used scheme in which the block that was referenced last recently is written back to the disk and removed from the buffer. So there is a removal of the buffer, there is a removal of the disk that is available with the scheme. That is the least recently used. This simple approach can be improved on for the database application. That is the database application that is also available to remove the databases. Then next is the pinned block. That is for the database system that is to be able to recover from the crashes. It is able to or it is necessary to restrict those times when a block may be written back or written back to the disk. That is a disk block. A block that is not allowed to return back to the disk is said to be pinned. So that is not allowed to the other block that is referred as a pinned. Then next is forced output of block. That is a forced output means displaying the forced output of the blocks. Then force output blocks mean there are some conditions in which it is necessary to write back the block to the disk even though the buffer space that it occupies is not needed. If there is no needed of the block, that is also then you also need it for the separation of the disk, separation of the forced output. This write is known as the forced output of a block. That is forcefully we are blocking out, forcefully we are taking out of the blocks. We shall see the reasons for forced output in chapter number 16. That is briefly main memory content and therefore buffer contents are lost in a crash, whereas data on a disk usually survive a clash. That is also available in the disk blocks. Now next is the buffer replacement policies, that is what are the various policies to replace the buffer so that one buffer cannot be used with the another buffer. That is the buffer replacement policies. Now what is the main goal of the replacement policies is to minimize the accesses to the disk. So if I want to minimize the various accesses in a disk, that will be done or that will be referred by the buffer replacement policy. So goal of our replacement strategies in the buffer is to minimize accesses to the disk. That is there will be a minimum access to the disk, there will be a minimum read and write to the disk. For general purpose programs, it is not possible to predict accurately which blocks will be referenced, that is which block will be referenced, which content will be referenced. Therefore, operating system uses the past pattern of the block references as a predictor of the future references. That is also available for the disk block. The assumption generally made is that blocks that have been referenced recently are likely to be referenced again. That is, blocks that are in a reference recently are likely to be referenced again. Therefore, if a block must be replaced, the least recent used is replaced. This approach is known as the LRU, that is the least recent used. That is whatever the least recent used blockage or the block that is available, that is first replaced. That is for each tuple I of instructor do, then D of instructor do, then department name, begin. This is the begin part that is available with this one. So this is the procedure for computing the join. LRU is an acceptable replacement scheme in the operating system. So this is the LRU, that is the acceptable replacing scheme or the replacement scheme that is available in the operating system. However, a database system is able to predict the pattern of future references more accurately than the operating system. So to illustrate how information about future block accesses allows to improve the LRU strategies, consider the processing of the SQL query. So this is select star from the instructor's natural join department. So this is the buffer management should be instructed or to free the space that is occupied by an instructor block as soon as the final tuple has been processed. This buffer management strategies is known as the toss immediate strategies. And there is a MRU strategy that is also available, that is the most recent used strategy. For the MRU strategy to work correctly, for example, the system must pin the department block currently being processed. That is, a system must use the department block that is currently being processed. After the final department tuple has been processed, the block is unpinned and it becomes the most recent used block. In addition to using the knowledge that a system must have the request that is processed, the buffer manager can use the statistical information about the product. So there is statistical information that is also available about the product. The ideal database block replacement strategies need knowledge of the database operations, both being performed and those will be performed in the future. That is, one is performed in the database, that is performed in the future, that is one is the database that is or the block that is performed in the present. Now this is winding up of the chapter, and this is the crash recovery system, that is chapter number 16, that provides the various constraints on the disk replacement. So we are finished with this chapter also, that is the storage and the file structures. So next is the summary, that is a summary of this chapter. The first point says several types of data exist in most computer systems. That is, there are multiple data that is available in the most computer systems. They are classified their speed or by their speed and by their cost. So every data is classified by their speed and by their cost. Among the media available are the cache, main memory, flash memory, magnetic disk, optical disk, and the magnetic tapes. That is, among the various media that is available, there are multiple main memory or there are multiple devices that is available. That is known as the main memory device, magnetic tape device, and the magnetic disk, optical disk, and the magnetic tapes. Next point says two factors that determines the reliability of storage media. So what are the two factors that determines whether we rely on the storage media or not? Whether a part failure or system crash causes the data to be low. So one of the factor is that check it out whether the data storage or whether that is stored is being lost when the power has gone or when the power failure has come or the system crashes. This is checking out. Or next factor is that what the likelihood is of the physical failure of the storage device. That is, what is the main reason for the storage or what is the main reason of the physical failure of the storage device. That is, how to fail the physical storage. The next point or the third point is that we can reduce the factors or we can reduce the likelihood of the physical failure by retaining multiple copies of the data. For this we can use the mirroring, that is known as the RAID, that is a redundant array of independent disk, and there are 6 levels of the RAID, that is start from the 0 and end with the 6, 0, 1, 2, 3, 4, 5, 6. Next, we can organize the file logically as a sequence of the records that is mapped onto the disk block. So we can recognize or we can record a file, we can recognize a disk that is available as a sequence of record that is mapped onto the disk blocks. Next point says the data are transferred between the disk storage and the main memory in the units of a block. That is, whenever we store the data in the files, they are logically divided into the various blocks in which the data will be stored. So first of all, there is a concept of the files, then there will be a blocks in which the data will be stored in the form of the records. So first of all, there are the files, then blocks, and in the blocks there is a records. Records contains the information. Next point is data dictionary, that is also known as the data about the data. That is, we can store multiple data or multiple information about the data only. That is a data about the data. That is keeping track of the relation names attribute names, types, storage information, and also includes the constraint types, constraint information, that is the integrity constraint, key constraint, and more such information. Every information is stored in the data dictionary. Next is the next point says one way to reduce the number of disk access is to keep as memory blocks as possible in the main memory. So if I want to reduce the number of disk access so that the speed will be high and the cost will be lower, so we have to maintain, or we have to keep as many as block as possible in the main memory. That is, we can divide the main table, we can divide the main file into number of blocks that is used in the table. That is dividing the main memory, dividing the main block, dividing the main file into the multiple blocks, so that the access time is lower and we can store the data, we can save the data in a much faster way. And buffer is that part of main memory that is available for the copies of the disk blocks, and everything that is responsible for this one, that is known as the buffer manager. These are the various review terms that is also used in this chapter. This is the practice exercises. Then these are the various exercises that is available in this one. Now that's all for chapter number 10. Next is the chapter number 11, that is the indexing and hashing. That is, what is the index method and what is the hash method that is used for the database file structure, that is used for the database accesses. That is the chapter number 11, that is the indexing and the hashing. So this I'm going to start on in the next class, that is in the Monday's class. So that's all for today's session, and in the Monday's class I'm starting a new chapter, that is chapter number 11, that is the indexing and the hashing. So that's all for today's session, and if there is any doubts, any suggestions, you can ask the doubts, and please read these concepts. These are the important concepts. That is the part 3 is more important because this is all about the file structure, storage, everything that is related to the databases, right? So that's all for today's session. Thank you so much everyone for listening me. We will meet on Monday with the new chapter, that is chapter number 11, that is the indexing and hashing. All right. So thanks a lot. Bye bye everyone.